Hey everyone, welcome back to the channel with today's LeetCode DCC question, linked list cycle. This question has been asked in previous interviews of Amazon, Spotify, Microsoft, Oracle, Visa, Google, and Goldman Sachs as well. Let's look at the problem statement. Given head, the head of a linked list, determine if the linked list has cycle in it. So we have to determine whether there is a cycle or not. And they have also given the definition of a cycle. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. That means, suppose there is a list and this is the head, and now it is connected to the head. So if this is the list starting from the head node, so we will follow the next pointer of every node and we will travel. Now the next pointer of head node is pointing to this node. The head pointer of this node is pointing to this node. Head pointer of this node is pointing to this node. Now, head pointer of this node is pointing to such a node which we have already visited. That means we have reached some node again by following the next pointer. So, there is a definition. There is some node in the list, that can be reached again. So, we have reached this node again by continuously following the next pointer. So we have followed the next pointer of each node and we have reached this node. That means if such cases arises, that means yes, there is a cycle in a linked list. Else there is no cycle, right? So how we can solve this question? Now let's suppose there is a garden and there are four benches around it. And there is a boy who was running around this garden and want to track off the number of rounds he completed. So for what? For that, what he did, he kept a piece of paper, and in that, for every bench he visited, suppose the bench number is assigned to every bench. For that, what he did, every bench he visited, he keep track of the bench number. Now, starting from the now suppose this boy started from bench number one. Say he wrote bench number one in the piece of paper. So he's running and reached bench two. Now again he see whether we in the piece of paper bench 2 is written or not. So he sees bench 2 is not written. That means he haven't completed one round. Now bench 2. He wrote bench 2. Now again he reached bench 3. He will see bench 3 is not written. He will write bench 3. Again he reached bench 4. In the piece of paper bench 4 is also not written. That means still he haven't completed one round. Now he reached bench 1. In the piece of paper he will see yes bench 1 was written. That means he have completed now one round. So same logic can be applied in this question. Suppose we keep track, suppose in this example, the address of this node is 100, 200, 300, and 400. Now, the nodes we are visiting, if we keep track of the address of that node, then let's see whether we can find out the cycles in the linked list or not. Now, suppose we have a data structure where we can store the address of a node. Starting from the head node, we will store the address. Now 100 is stored. Now next pointer of 100 is pointing to address 200. We will see whether we have stored 200 earlier or not. So we will see 200 is not stored earlier. That means there is no cycle. We are not revisiting. This is the first new node we are going to visit. So we write 200 in there. Now 200 is pointing to 300. So again we see in this storage, there is means 300 is not present. That means this is the new node which we are going to visit. So we will write 300. Now 300 is pointing to 400. Again, we can see 400 is not written there. That means 400 is also a new node which we are going to visit. Now 400 is pointing to 200. And we will see in this storage, yes, 200 is present. That means we have already visited 200 earlier. So whenever we are visiting the nodes, if we see the sum at the next pointer address is already present in this, that means there is a cycle and we are reaching same node again. So in this way, we can find out the cycles in a linked list. And what I said that we are storing this address, right? So to store this address, we can use any of the data structures like set or map, because every time we don't want to traverse the whole data structure and see whether this address is present or not. We want to check this address in one time, right? So we can use either set or map. So in this way, the time complexity of this will be somewhat greater than big O of n, and the space complexity will be big O of n. Now, whether we can reduce this space complexity or time complexity or not. So time complexity we cannot reduce, because if there is no cycle, ultimately we will travel each node, right? So time complexity will take big O of n. And space complexity, let's see whether we can reduce the space complexity or not. Now let's see one more approach. Now suppose again there is a circular path and there are four spots, and there is an Alice and a Bob. Alice is angry with Bob, and initially both are present in this spot 1, spot 2, spot 3, spot 4. Now there is a condition that Alice takes one jump, and Bob takes two jump. And Bob is chasing Alice. Let's see whether Bob can chase Alice or not. So if they are running in a circular track, now if we see at time t1, Alice and Bob both are at starting at same position. Now at t2, Alice jumps to spot 2 and Bob jumps to spot 3. One spot and again two jump. At t3, Alice jumps to s3, Bob jumps to s4, then s1. At t4, Alice jumps to s4 and Bob jumps to s3. At t5, Alice jumps to s1 and Bob jumps to, if we see from s3, it takes to one jump here and next jump here. So at t5, we can say Bob jumps to s1. So at this point, we can see both Alice and Bob are meeting again. That means if one guy is taking little bit more jump, like greater than Alice. So Alice was taking one jump and Bob was taking two jumps. So if any of the guy is a bit faster than other guy, then and both are running in a circular track, then they will definitely meet each other again, right? So we can also apply this algorithm in finding the linked list. Suppose if we take this example, now let's take this example. Let the address of this node is 100, 200, 300, and 400. Now, suppose we have one Alice and Bob. Both are now at 100. Now Alice takes one jumps and reach to 200, and Bob takes two jumps and reach to 200 and then 300. Again, Alice takes a jump from 200 to 300, and Bob takes a jump from 300 to 400 and 400 to 200. Now again, Alice takes a jump from 300 to 400, and Bob takes a jump from 200 to 400. So again, we can see they have met again. That means why they have met again? If there was not a circular loop, they haven't met it again, because if there was a straight line and if one guy is jumping one steps and another guy is jumping two steps, then the slower one will always be behind the faster one. But in this case, we can see both are meeting again. That means they must have been in a some circular path, right? That's why they are meeting again. So if such cases arise, if they meet again, then we can say yes, there was a cycle in a linked list. Now let's take this example. In this example again, let's suppose the address of this node is 100, address of this node is 200. Alice address 100 and Bob is at 100. Now Alice takes one jump and reaches 200. Bob takes two jumps from 200 and again 100. Again, Bob is at 100. Now again, Alice takes one jumps. He's at 100 and Bob takes two jumps. That means 200 and again 100. Now again, we can see they both met. They both met means they must have been in some circular path. That's why they are meeting it again. Though their difference, speed difference is different and they're meeting it again, that means they must have been in some circular path. So again, for this, there is a circular path. Now for this, Alice is at 100 and Bob is at 100. Now for Alice, there is no next path, and for Bob also, there is no next path. So we can say there is no cycle. Now let's try to code. So for this, suppose we have Alice who is pointing to head, and we have Bob who is also at head position. Now, while so Bob is running at a faster rate. So if there is no loop, that means Bob will reach the end first. So we will write if Bob is not equal to null, or and Bob next pointer is also not equal to null. In that case, Alice will take one jump and Bob will take two jump. Now, after taking jump, we will check whether Alice and Bob are at same position or not. If they are at same position, that means they must be in some circular path. Then we can return true. And if we reach end, if we reach the end, they haven't met at any time. In that case, we can return false. Let's try to run the test cases. So test cases has been accepted. Now let's try to submit the solution. So solution is accepted. I hope the problem statement and the solution is clear. If you have any questions, mention in the comments below. See you in the next video. Thank you.